Number 21, write a rational function with a vertical asymptote at x equals 4 and a hole at x equals -3. Your function should not include any parentheses. Well, first of all, it is a function, so we do want to make it say y equals. Okay, and then we want a vertical asymptote at x equals 4. Vertical asymptotes occur at non-removable discontinuities, and holes occur at removable discontinuities. So we know discontinuities have to do with the denominator equaling 0. So I'm going to start with my vertical asymptote. I know that there has to be a discontinuity at x equals 4. So if I put x minus 4 in the denominator, if I were to plug in 4, the denominator would equal 0. So I know that that's good. And since I don't want it to be removable, I'm not going to put anything up in the numerator to cancel out with it. Okay, since there's a hole at x equals -3, again, there is going to be a discontinuity. So if I put x plus 3 in the denominator, if I were to plug x equals -3 into the denominator, I would get 0, which makes it a discontinuity. Since I want it to be a hole, it needs to be a removable discontinuity. So if I put an x plus 3 in the numerator as well, the x plus 3's would cancel, creating the hole. Okay, so now it says my function, if you want to add anything else to it, you certainly could. If I wanted to add a 5 or 2, whatever. And then it says your function should not include any parentheses, so now I'm just going to multiply things out to make sure that there are no parentheses. So I'm going to have x plus 3, and again, I apologize for my sloppy handwriting. I'm trying to write this with a mouse click, which is pretty interesting. Okay, so I have x squared. I'll get plus 3x minus 4x, which will give me minus x, and then minus 12. So that's what a possible function would look like.